Hi, what's up, guys? I am back again. So I'm going to go ahead and uh, give you guys an explanation of how to do this lesson. So lesson 80, calculating frequency distributions. And I'm going to go ahead and just start it right off with example 1, then I'll move on to example 2 and example 3. So example 1, it says, so we're using experimental probability. So a baseball player bats multiple times in a season. The table shows the result of each bat. Make a bar graph that shows the frequency distribution of the data. So we're making a bar graph. Find the experimental probability of each outcome. Okay, so that's the new thing that we're doing here is we are doing experimental probability of an outcome. So if you look back on, so we are on page 523 right now. So if you look at those new concepts, so we have discrete events. So discrete events have a finite number of outcomes, and then we have a compound event. And this is an event consisting of 2 or more simple events. A simple event could be tossing heads on a coin. A compound event could be tossing heads and then tails. So that compound event, essentially what we have is we have one outcome that can occur and then something else happening. So I toss my penny and it lands on heads the first time I throw it. The second time it lands on tails. So that's a compound event. And then we have a frequency distribution that shows the number of observations falling into several ranges of data values. So we have tables, graphs, tree diagrams, and the list. And lists are used to show frequency distributions. So that's what we have right here. My spotlight. So we have our little chart right here. So go ahead and turn your page to page 524. So that's where I just read off our example. So this is our table that shows the batting frequencies. So this first one is the number of times that this batter in baseball was out. So every time he stepped up to bat, so there was 30 times that he was out. How many times was he walked? He was walked 36 times. How many times did he hit a single? So how many times did he go to first base? He went to first base 20 times. How many times did he hit a double? So how many times did he hit it far enough so he could run all the way to second base? He did that 9 times. And then how many times did he was he able to make it to third base? So hitting a triple, that was 3 times. And then how many times did he hit a home run? He hit 1 home run. So this is something that in baseball that they actually do with analytics. So I really like this example because this is a very relevant and common thing that statisticians do in statistics. So we have a little bit of the beginning of statistics here. So first things first, I need to add up the total number of times he batted. So total at bat. And how am I going to do that? I'm adding them all up. I have 30 plus 36 plus 20 plus 9 plus 3 plus 1. So I'm adding up all of those different times that he was up to bat. So first off, 30 and 36, that's going to give me 66. And then 66 plus 20, that's going to give me 86. And then 86 plus 9, that's going to give me 95. 95 plus 3, that's going to give me 98. And then 98 plus 1 will give me 99. So 99 was my total, was this baseball player's total at-bats. So get that written down. I'm going to erase all this now, since I know the total at-bats, because my screen doesn't have enough room. So my total at-bat, 99 times. So how are we going to find our probability of each one? Well, what I'm going to do is write P for probability. So probability that he will be out. So this is how you write it. So P, probability of being out. So P out equals, so he was out 30 times out of 99. So 30 out of 99 times. 30 out of that total 99. And can we make this a smaller, so can we reduce this fraction? Yes, we can. So 3 goes into 30, and then 3 also goes into 99. Divide by 3, divide by 3. That gives me 30 divided by 3 is 10. And then 99 divided by 3 is 33. Hang on just one sec. I got to get my power cord. Got to plug in my laptop here before it dies. Okay, so then go ahead and find the probability of being walked, the probability of hitting a single, the probability of hitting a double, the probability of hitting a triple, and then the probability of a home run. So pause the video so you can get all of those real quick, and I'm going to go ahead and do them. So go ahead and resume once you get all of those total probabilities. Okay, so the probability of this baseball player being walked, so P walk, probability of being walked was 36 total times out of 99. That cannot be reduced, so that is my my smallest fraction there. So I have 36 out of 99. My probability of hitting a single, P single, will be 20 out of 99. Okay. Cannot reduce there. And I just noticed, now that I'm looking at it, the probability of being walked, there is something that goes into both of those there. It's going to be 9. Divide both top and bottom by 9. So 36 divided by 9. Hold down my whichever finger it was to create. So that would be my 4th finger to make 30, and then 6. For you guys, so I can show you the right way. So it's my 4th finger. So 30, so 1, 2, 3, and then 6. 1, 2, 3, 4, 5, 6. 36. That's my 4th finger out of 11. So 99 divided by 9, we all know that's 11. Okay, so 4 out of 11. The probability of being a single, there's nothing that goes into both 20 and 99. Probability of a double, we have 9 out of 99. Divide the top by 9, divide the bottom by 9. We get 1 over 11. Cool. If you need to get these all written down, I'm about to get rid of these 4, so I have enough room for my triple and my home run. Get those written down. I'm just going to erase those two for now. Okay, so my probability of hitting a triple equals 3 out of 99. 3 goes into both of those, as we saw in the amount of times the player was batted out. Same factor there. So 3 divided by 3, 1. 99 divided by 3, 33. So 1 over 33. And then the probability of a home run was very low. So that's what my HR stands for, short for home run. So probability of a home run, 1 out of 99. Okay, not too bad, right? So that's how you get the probability. Okay, so that's how you write it out. Now you need to graph all this out in a bar graph form. Okay, so I'm gonna get all this erased. I'm actually going to pause my video so I can get the bar graph created here. So that's going to take a little bit. Okay, guys, I have my graph made here. So I have my frequencies. So 0 all the way to 50. It doesn't even go to 50. The highest it goes is 36. So as long as I make my graph up to about 40, then that'll be okay. Over in your book, they made it all the way up to 60. That's a little overkill, but all you really need is for it to go up to 40 because 36 is your highest point. Okay, so my red is going to be standing for the amount of time someone is out. Okay, so my number for that is 30. Okay, so I'm going to attempt to make my bar here. Let's see how. I'm going to try something new. I'm going to try this little thing. So it goes up to 30. Oh, sweet. Goes up to 30. Okay, that's kind of cool. So 30 is my number for the number of outs. That's so cool. Okay, and then my number of walks is yellow. We got yellow, highlight that. My number was 36, so that was our high number. So drawing that out, do this, goes up to 30, about 36. So go, my 35 is about there, a little bit higher. That's about 36. And one thing you can do when you're creating bar graphs is you can always, so on top, you can always write, if it's kind of hard to tell like this one is, you can write your number on top of it. That's something very common you will see in bar graphs. So you can write your 36 above your walks. You could write a 30 above your outs. And then single, go for single. That was my green. So single. There was 20 singles. Okay, so create my bar. Go up to 20. So the second line. Sweet. And I would like you guys to make one of these yourself in your notes so you can know how to do it yourself. I'm going to write the 20 above that. So 20 singles. You can do color code like I am if you have it. And then my doubles, that looks like blue, I think. Double my blue, that goes up to 9. Alrighty, make my blue bar. So it doesn't quite go all the way up to that first line. If it was a 10, then it would go up to the line, but I'm going to make it slightly below. That's going to be my 9. We got a 9 right there. Sweet. Triple, pink. highlight triple. There was 3 of them, so that's our lowest frequency, so that's going to be barely anywhere. So when I make my little bar, it's going to be, so I have a 5 as my middle line, so it's got to be slightly below the middle. Yeah, about there. That's not quite halfway. So that was my 3, so the amount of triples he hit, 3 of them. And then the amount of home runs was only 1. That was my orange. So it's going to be barely anywhere. Lower than that one, that triple. So just a little guy there. Only 1 home run. He is not a very good hitter. Sweet. So there is my frequency bar graph for example number 1. And if you look at your how they did it in your book, it is very identical to how I made mine. Okay, now we're going to move on to example 2 on page 525. So that's going to be representing data with a table. So I'm going to get my screen cleared here, and then I'm going to move on to that one. Okay, guys, I got everything drawn out here for what we're doing in this problem, so example 2. So we are representing data with a table. So a student spins the spinner and flips a coin. So we have 2 different outcomes here. So this is one of our compound events. So we are spinning the spinner. So I made my spinner right here. We have red, blue, yellow, and then red again. So that's one possibility. And then we are also flipping a coin. So what is going to be the probability of when you're flipping a coin and when you have a spinner that has 4 different possibilities? So I drew out a graph here, a little chart, I should say. So I wrote red, blue, red, and yellow, because that's one of my possibilities, is getting red, getting blue, I have red again, and then I have yellow. And then I am flipping a coin. I have heads and I have tails. So that's what I wrote down here. I have heads and I have tails. So what is the probability of getting a red and a heads? Well, all I'm going to do there is write R for red and H for heads. So that's one of my probabilities. My next one is I have the probability of spinning the spinner, it landing on blue, and me flipping a heads. So it's going to be, as you can see, it's going to be heads all the way across. So what's the probability of me spinning my spinner, it landing on red again? Well, I have red right here, and I have heads right here. What about yellow? Well, I would write Y for yellow and H for heads. Okay, so that's all of my probabilities of rolling or flipping a coin and getting heads. So what about tails? Well, tails is going to be the same for everything right here. So I'm just going to put my T all the way across, just like I did for heads. And then what is my probability of getting a red? I'm going to put R right here, of getting blue, B right here. How about red again? Another RT, and then yellow, YT, yellow and tails. So as you can see, we have a really high probability of getting red, more so than any of them. And then heads and tails is our 50-50 shot. Okay, so what does letter A say? So make a table to show the possible outcomes in this experiment. Okay, we just did that. And then find the theoretical probability of each outcome. Okay, so theoretical probability. That's what we were just doing in our example number 1. So I would say, what is the probability of getting, let's go with red and getting a heads. So RH, red heads. So I can get it, spotlight, I have one chance right here, and then I have two chances right here. So 2 out of how many? 1, 2, 3, 4, 5, 6, 7, 8. So 2 out of 8, or 1/4. 2/8 or 1/4. So I have a 1 out of 4 chance of getting a red and a heads. Okay, so what's my probability of getting blue? So probability of blue and flipping a coin and getting heads. So I have 1 blue heads right here, and that's it. So 1 out of 8. 1 out of 8. That's it. What about, we already did red and heads, so we're going to go on to probability of yellow heads. Again, that's going to be the same as blue. There's only 1 out of 8 chances that we would get our spinner to land on yellow, and for us to flip a coin and for it to land on heads. Okay, so we have to have both of those things happen for us to get a yellow and a heads, or a blue and a heads, which makes sense when we look at our little chart right there. Okay, now let's move on to tails. So what's the probability of us getting a red and the tails? That's going to be the exact same as our red and heads. So 2 out of 8, which also equals 1/4. Probability of blue and tails, the exact same as our blue and heads, which makes sense. Probability of yellow and tails, 1/8 once again. Okay, so that would be us calculating our theoretical probability of each outcome. And why is it theoretical? Because this is a theory. We are listing all of our possible outcomes of getting each different possible outcome. Okay, I'm going to get my whole screen erased again, and I'm going to get example 3 up. And then that'll be the last thing before you can move on to your homework. Okay, guys, for our last problem, our last example here, we have representing data with a graph. So we're creating another graph here, just like example 1. Okay, so we have the letter M in Mississippi. So suppose that 11 cards each contain 1 letter from the word Mississippi. So we have in the word Mississippi, we have an M, or the letter M, we have the letter I, we have the letter S, another S, another I, another S, another S, another I, a P, and then another I. Okay, so for our frequency for the amount of times that M shows up. All right, so for M, I'm gonna have that be red. Okay, so for M, we have only 1 M. Okay, so I'm going to go up to 1 right there. And then I'm going to write out 1 right on top to show that, just to make it a little bit more easy to read to the eye. Okay, and then how many I's do I have? So I'm going to count how many I's I have in Mississippi. So I have 1, 2, 3, 4. Okay, so 4 I's. So that's gonna be my yellow box. That's gonna go up to that line right there. So 4 total. 4 of them total. Cool. Okay, how many S's do we have? So the third letter is an S, fourth letter is an S, that's 2, and then 3, 4. So there's 4 of them in Mississippi. So use my green. Go right up to the 4, right next to the I. Put 4 right above it. Cool. And then how many P's are there? There's only 2 right towards the end. Only 2 of them right towards the end. That's going to be blue. It's going to go up to my 2. Cool. Oh, a little bit higher. That's going to bug me. Number 2, right above it to show how many P's we have. And that's all of them. And double check that we did count them all. So I have 2 P's plus 4 S's, that's 6, plus 4 I's, that's 10, and then 1 M, that's 11. So how many cards are there supposed to be? It says in the problem, suppose that 11 cards each contain 1 letter from the word. Okay, so that means we have our total of 11. So we got our graph correct. Now, so that was letter A, we need to find the theoretical probability of each outcome. So theoretical probability, just like we did in letter A and letter A, just like we did in example 1 and example 2, we are just finding the probability of each letter compared to the total. So we're going to do that in fraction form again. So for our letter M, I'm going to do this in red since my M is red. So probability of getting an M equals 1 out of 11. And why is it 11? That's because that's our total number of letters in Mississippi. Now, my yellow, my probability of getting an I equals 4 out of 11. That cannot be reduced again. Now, my probability of getting an S, so P times S, so we have 4 out of 11 again. Now my probability of getting a P is 2 out of 11. And that's it. So good luck on the rest of your guys' homework, and that's all I have for you. So good luck on your homework. Bye.